Our planet faces an energy crisis. We are running out of fossil fuels, and the pollution from these fuels is harming our environment. Scientists are searching for alternative energy sources. One such source lies not on Earth, but on the Moon. It is a rare isotope called Helium-3. Helium-3 has the potential to revolutionize energy production. It could provide a clean, safe, and nearly limitless source of power. Helium-3 is a light, non-radioactive isotope of helium. It is extremely rare on Earth. However, it is abundant on the Moon. The Moon has been bombarded with solar wind for billions of years. This solar wind has deposited large amounts of helium-3 in the lunar soil. Scientists estimate that there are millions of tons of helium-3 on the Moon. This is enough to power the entire world for thousands of years. The potential of helium-3 is immense. It is a game changer in the quest for clean energy. Helium-3 fusion does not produce greenhouse gases. It also generates very little radioactive waste. This makes it a much cleaner alternative to fossil fuels and even traditional nuclear power. The prospect of harnessing this lunar resource is a beacon of hope for a sustainable future. The journey to unlock the power of helium-3 is fraught with challenges. It is a journey that will require international collaboration, technological innovation, and a bold vision for the future. The promise of helium-3 is a testament to human ingenuity. It is a reminder that the solutions to our most pressing problems may lie beyond our home planet. Helium-3 was first discovered in 1934. It is a byproduct of the nuclear reactions that occur in the Sun. Helium-3 is a light isotope. It has 2 protons and 1 neutron. This is in contrast to the more common helium-4, which has 2 neutrons. Helium-3 is a fascinating element with unique properties. It is a stable isotope, meaning it does not decay over time. Helium-3 remains a liquid even at extremely low temperatures. This makes it ideal for use in cryogenics and other scientific applications. Its scarcity on Earth is due to our planet's protective magnetic field. It prevents most of the solar wind carrying helium-3 from reaching the surface. The Moon, lacking such a shield, has become a reservoir for this valuable isotope. Helium-3 is the key to achieving nuclear fusion. Fusion is the process of combining atomic nuclei to release energy. This is the same process that powers the Sun. Fusion reactions using helium-3 are particularly attractive. They produce far fewer neutrons than other fusion reactions. This means less radioactive waste and a safer reaction process. The scientific community sees immense potential in helium-3. It could revolutionize fields beyond energy production. It can be used in medical imaging, quantum computing, and even in the development of advanced spacecraft propulsion systems. Understanding the properties and potential applications of helium-3 is crucial. It is the first step towards harnessing its power for the betterment of humanity. The abundance of helium-3 on the Moon has sparked what some call a lunar gold rush. Nations and private companies are now looking at the Moon with renewed interest. They are driven by the potential of helium-3. The race is on to develop the technology and infrastructure needed to mine the Moon. Mining helium-3 on the Moon, however, is a daunting task. It presents significant technological and logistical challenges. The Moon's harsh environment, lack of atmosphere, and extreme temperatures pose significant obstacles. The extraction process itself is complex. It involves heating lunar soil to high temperatures to release the trapped helium-3. Despite the challenges, the potential rewards are too great to ignore. The successful extraction of helium-3 from the Moon would be a game changer. It would pave the way for a new era of energy independence. It could potentially end our reliance on fossil fuels. The economic implications of lunar helium-3 mining are far-reaching. The development of a lunar mining industry would create countless new jobs. It would lead to technological advancements in robotics, space exploration, and resource extraction. The control and distribution of this valuable resource could also reshape the global geopolitical landscape. The promise of helium-3 as a clean energy source hinges on our ability to achieve practical fusion power. Fusion power has been a long-standing goal of scientists. It has remained elusive. Fusion reactions require incredibly high temperatures and pressures. These conditions are difficult to create and maintain here on Earth. Despite the challenges, progress is being made. Scientists have made significant strides in fusion research. Projects like the International Thermonuclear Experimental Reactor, ITER, are pushing the boundaries of fusion technology. ITER is an international collaboration aimed at building the world's largest fusion reactor. The successful development of fusion power would be a monumental achievement. It would be a triumph of human ingenuity. It would mark a turning point in our quest for sustainable energy. However, it is important to remember that fusion power is not a silver bullet. It is not a quick fix for our energy problems. Even if we successfully develop fusion technology, there will be challenges to overcome. The construction and operation of fusion power plants will be expensive. The distribution of this power will require significant infrastructure development. While fusion power holds immense promise, it is essential to approach it with a healthy dose of realism.